Okay, here is a practice test I gave my Chem 30s that covers thermo and electro, just looking at this, before we did their first midterm. So this first question, taking a look at it, we have some information, and then we have the net ionic equation. And in this question, there we go, we are asked the first part, what is happening at the cathode? So taking a look at our two reactants, so you have water present as a liquid, and then you have chlorine, the ion present in the aqueous state. So those are our two reactants, and if we're at the cathode, your cathode is going to gain electrons, right? Cathode undergoes reduction. Reduction is Rig, so we're looking for the gaining. Chlorine already has a negative charge, so this one here is the OA, and if we show that gaining electrons, the answer is D. This next part, because this is a electrolytic cell, meaning we need to put in energy, if we turned off the current to force that reaction, what would start happening? So this first one's saying that about pH stops decreasing. That could possibly be the case because we do see OH being formed, but OH is making it more basic. So in terms of your pH scale, you would stop increasing. So that's why that's not correct. The next way pH starts decreasing, that's not going to happen. pH would just remain constant if the cell stopped. C and D, talking about the concentration of the Cl negative, would stop decreasing. That would be the answer because the Cl negative is a reactant and it's being used up as the reaction takes place. This last one, D, about the concentration of Na positive. Well, in this equation, this is not part of the redox equation. So Na positive was present, but it's not what's in our reaction. So the answer there was C. This next one, looking at balancing, there's a few ways you can do it. I think in this one, you could either apply your oxidation numbers and then balance in that way, or realize that you are in acidic conditions and come up with your two half reactions, which I think a lot of times that way is easier for kids. So let's do that way first. So you have AS2O3, and that's forming ASO4. So we're going to balance the AS by putting a 2 in front of our product. Then we're going to add in one water molecule. Not one, sorry. 2 times 4 is 8. Minus 3. So we need 5 water molecules to balance out the oxygen. And now we have 10 hydrogens, so we'll have to add in 10 hydrogens to balance out the hydrogen. And lastly, electrons. So on the left-hand side, you have no charge, and on the right-hand side, you have a positive 10 as a charge, so we'll add 10 electrons to the right-hand side. The second half reaction is the reaction with chlorine. So you have Cl2 making Cl negative. So here we just have to balance out the chlorine and then balance out the charges. So that is our first step. From there, we know that to balance this out, we're just going to have to multiply this reaction by 5 and everything would be balanced. So just answering the question now, if you wanted to, you could rewrite everything, but we can just take a look at what's happening. Only the electrons would end up canceling. So you'd have 5 water molecules, 1 of the AS2O3. On the right-hand side, you have 2 of the ASO4. And then if you had 5 times the 1 here, we'd end up with 5 of your chlorine molecules. This next one, looking at electroplating. If you were going to electroplate onto this car bumper, this would be your cathode. Here it's asking about the anode. So just reading this over, we have the first step is to clean the bumper. The second step is to electroplate nickel onto the bumper. So if nickel is what's being plated, then that would happen at the cathode. So you'd have nickel 2 positive joining together with nickel ions to form nickel solid. So the reaction that would support that would be, which one are we looking at here? Anode. Oh wait, sorry, that's what's happening at the cathode. At the anode, when this reaction is being forced, nickel is going to break up into nickel 2 positive and its electrons. Electrons, of course, going over to the bumper, and the nickel 2 positive would end up in solution. So that is showing A, our reaction at the anode. This next one is a common question when it's asking about what order we are being reduced. When you're looking at being reduced, you are going to look for your strongest oxidizing agent, and then it goes down to your weakest oxidizing agent. So you would just look at page 7, and if you look at page 7, your order is copper first, the ion, then tin's ion, then fluorine's, if not fluorine, that's iron, iron's ion, and then chromium's ion. So if we're answering this, it would be 1, 3, 2, 4. So just looking at page 7. Moving on, this one is about, again, electroplating, and it is going to, what are we plating here? We're going to plate chromium. So when you are electroplating, even though you do have enough to come up with the whole redox reaction, you only ever need the half reaction. So the half reaction from chromium being plated, so from here we know 2 positive ions would be present. It would have to gain 2 electrons to form chromium solid. So if it's asking about the time, we are going to use the formula, but we need to get to moles of electrons first. So we would set this up and get that solid chromium, which we know the mass of is 125 grams. So you'd have 125 grams, and you want to multiply this by the molar mass of chromium, which is 52. That way grams can cancel. Now to use the formula, you need moles of electrons. So now we can use the mole ratio to turn moles of chromium into moles of electrons. So this is in moles. And then we have 1 mole of chromium. So that will cancel. So now that you have moles of electrons, and that is what our formula is, you have moles of electrons will equal your current times your time divided by Faraday's constant. So we have moles of electrons now. We can get that answer, plug that into your calculator, and that would be your moles of electrons. We also have the current, so we have I, we know Faraday's constant. If you don't remember it, it's on page 3, and we want to solve for the time. So you would get with all of this that your time will equal 123.7 seconds, but then your choice is all in minutes. So just divide this by 60 and you'll see your answer is C. Now we have one with our titration, and you probably did a similar titration in your class. My class did this as well. Permanganate is this really dark purple color. So we are titrating with an acidified solution. So what we'll need to do first is come up with that balanced chemical equation. And so you take a look at what's reacting. So you have, it's acidified, so you have hydrogen ions present, you have H2O2, and you have permanganate, so the potassium ion. You would also have MnO4 and water present. So we have everything that's listed. You want to pick your OA, your RA, that's strongest, and then come up with that reaction. So to do that, it would end up being, for your balanced reaction, 2 MnO4 plus 6 hydrogen ions plus 5 H2O2 to give you 5 O2 plus 2 Mn2 positive plus 8 water molecules. So now that we have that, we can set up our stoich to figure out the concentration of the peroxide. So that's what we're solving for. The volume of each of your each of your samples was 20 mils. And then coming over to the MnO4, we know the concentration of this is 0.150, and we can figure out the average volume. So first, when we're taking a look at this, you do want to make sure we want to include all values. So the fact that that first trial is purple and not in range with the other 3, we're not going to include it. So we're going to take the average volume of the other 3 trials, which will be 16.4 milliliters. So 16.4, so 0.064 liters. You want to multiply this by your concentration. So the average here was 16.4. So I'm multiplying by my concentration so that liters can cancel. And then I now am at moles of my known, and now I can use the mole ratio to turn it into moles of my unknown. So that is a 5 moles of H2O2 over 2 moles of your MnO4. And then lastly, I need to divide by the volume I am using. And again, every sample was 20 mils, so 0.02 liters. And you would get 0.307, and that would be moles per liter. And then in this case, because we would want just 2 sig digs, this will be 0.31 moles per liter. Taking a look at number 5, asking about bromine, which is brown, which of the following metals would not cause a bromine solution to change color? So this is asking essentially which one would not cause a reaction. So if you're not causing a reaction, your Ra would be higher on the table than your OA. In any other situation, it would react and you would have a color change. So if you take a look at your bromine solution, bromine is an OA. So bromine liquid, you can find this on page 7 as an OA. And when you're looking at your options, gold is the only one that's above it. All the other 3 will end up being below, which would mean it was spontaneous. So gold's the only one, Ra, that's above. Here's a nice, more simple question in terms of oxidation numbers. So this one's asking our oxidation number for manganese. And it says, which one would it be +6? So not this first one, because that would be +2. In the second one, it would be -3. In this third one, it would be, so MnO4 negative. This would be -2, would be +7. And then in that last one, taking a look, we would have -2, so -8, so it would have to be +6. So this last one was just D. Okay, moving on, we have an acidic solution of nickel 2 nitrate is poured into a tin container. So if we take a look at what we have reacting, you have nickel 2 positive, you have NO3 negative, we have tin solid, and it's acidic, so you have hydrogen ions present. It's in solution, so it would be also containing water. So now that we know that, and if you come up with page 7 and take a look at what's reacting, you'll see that your nitrate ion with the hydrogen is your strongest OA. So we have the nitrate ion, NO3 negative, reacting, and there's 2, once we balance this is just looking at page 7, plus 2 electrons to give you N2O4 and 2 waters. Okay, then the second part is tin is your strongest Ra, so tin solid reacts and it will give you Sn2 positive plus 2 electrons. So here's our 2 half reactions that we could add together. So now going through what we're seeing here, our first one, what is being oxidized? So oxidation involves loss. So tin solid is what's losing electrons, right? It's on the reactant or product side. So that would be number 2. So I'm just not reading this in order. What is being reduced would be the nitrate ion and hydrogen there. So we would put number 3. Keep going here. So we have that. Does not react. What's not reacting in here is the nickel 2 ion, right? Because that is on the product side. So that would be number 1. And lastly, reacts, but there's no change in its oxidation number. That would be your hydrogen. And you can take a look at that by seeing what we have. Okay, this next one takes a little bit more time because you are building tables. And then we will take a look at the strongest weak oxidizing agent. So looking at your first bit here, you have In and La3 positive with no reaction. So when we're taking a look, positive charges like to gain electrons. So this would be undergoing reduction, making La3 positive your OA. So the other one would be your Ra. So when you go to make your table, we know that La3 positive has to be lower on the table then your IN. And then you can fill in the rest. I'm using the rest of this to somewhat help. So I have IN3 positive and La solid over here. So that's our first one. Now looking at the next one where we do see a reaction, you have NP with La3 positive. So now your OA, which is already on the table, has to be higher up than your Ra. So we can fill that in, and I'm just not including electrons because I'm just looking for placement. Looking at reaction 3, we have NP and ND3 positive. So if I continued my table over here, my NP was already written, so up next would be the ND. So I'll put that here. Oh, taking a look at that. ND has to be higher. Okay, so ND has to be higher than NP, but I'm not exactly sure where to put it. So let's look at the next one just to have an idea. And if it says La and ND3 positive have no reaction, that means your Ra would be higher up. So the ND would have to be right in the middle. So now looking at your strongest to weakest oxidizing agent, your strongest is your top left. So IN3 positive is number 5. And then we would have 8 and then 7 and then 6 because we were just listing these in the order we would see them here. Okay, so looking at question number 7, we have, it's essentially like a theory question. We have a copper nail is plated with zinc metal using an electrolytic solution with zinc 2 sulfate and zinc metal at the negative cathode. Which statement is correct once a power supply is applied? So the first one, zinc cations are oxidized at the anode to produce zinc metal. That's not true. Zinc metal is undergoing oxidation, not the cations. So zinc cations are reduced at the cathode to form zinc metal. That is going to be the answer. So let's just make sure we understand it. So if copper is what's being plated, whatever is getting plated happens at, so it's a nail, so let's just pretend this is a nail, happens at the cathode. So this side here would be attached to the cathode, and your cathode undergoes reduction. It's going to gain electrons. Because zinc metal is being used at the anode, if you had a piece of zinc, it would be splitting up into zinc ions and electrons. Electrons are going to move over to the cathode, and then once they get there, it's going to pull the zinc 2 positive out of solution to make zinc metal. So now that we know that, we can just move on to the next one, talking about lifeguards that use sodium hypochlorite and hydrochloric acid in an electrolytic cell to balance the pH of the pool through filtration. And then it's asking the correctly balanced net ionic equation for this reaction. So let's see what is reacting here. And from this ionic compound, you have sodium ions, and you would have OCl, which is negative, which is your hyperchlorite. You also have hydrochloric acid, which is a strong acid, so H positive and Cl negative. We know we can break it up because it's strong. And you have water. So now going through, your strongest OA will be these two together, and your strongest Ra will end up being the chlorine ion because of the chloride anomaly. So even though water will look stronger, you want to pick chlorine. So now that we have the strongest, you can write your half reactions and then balance your electrons, and you will see when you add your net together, your answer will be D. Looking at our diagram, we have a cell, and we do see electrons are going from number 2 to number 1. So 2 would be your anode, 3 would be your cathode. So looking at what's reacting, we have your OAs, your RAs, and you also have an inner electrode to help this reaction. So your strongest RA is your nickel 2 positive. So this is going to be your anode, and the bromine part will be your cathode. So now that we know that, we can fill in the rest. So your nickel electrode is number 2. Bromine liquid would be shown by number 4 because it would be the solution at the cathode. The cation migration, cations always travel towards the cathode, so it would be 6. And your cathode is represented by number 1. Okay. So this next one about which ones represent an oxidation reduction reaction. Just taking a look at the first equation, to be a redox reaction, you have to have something undergoing oxidation and something else undergoing reduction. So if we look at the first one, we see Fe2 positive is turning into Fe3 positive, so it lost an electron. And Cr3 positive is turning into Cr2 positive, so it gained an electron. Because one thing is losing, the other is gaining, that is a redox reaction. So number 1 would be. Now, if you look at number 2 and you assign your oxidation numbers, you'd see that nothing is going to be changing, and so we wouldn't include it. So as we look at our oxidation numbers, or just those charges like we did in number 1, you see your answer here is 1, 3, 5, 6. Okay. Our next one here, now we're turning into more of the thermochem questions. So the second, or what I started with, that depends on your order, and it's asking about the molar heat of combustion. So to have the molar heat of combustion in terms of propane, you are going to have to come up with your balanced chemical equation. So you have C3H8 plus, it ends up being 5O2 to give you 3CO2 plus, and we have 4 water molecules. It's saying assume gas, which matters because it has a different value. So here you're looking at page 4-5. This is a Hess's Law short question, and we have to get all of our heats of formation. And so we would take a look, and you would look up, where is our propane value? There it is. It is negative 103.5. Oxygen would just be the 0. Then when you have 3 times your carbon dioxide, which is negative 393.5, and then you have 4 times your water value as a gas, which is negative 241.8. Now, if Hess's Law short, to get heat of the reaction, you take the sum of your products and subtract the sum of your reactants. And if you do that correctly, you should see your answer is B. Now, this next one, which of the following reactions represent a reaction in which the products can be classified as having a higher potential energy than the reactants? So if we drew out a potential energy diagram, if your products are higher than your reactants, you're looking for an endothermic reaction. So A can't be it because it's exo. This B is showing heat of formation of SO2. And if you take a look at your data booklet, that will be a negative value. C is showing ammonia decomposing. If you take a look at your data booklet for formation, it's a negative value, but if it's decomp, it would be positive. So the answer is C, and the last one we rule out because it's negative. Okay. This question number 11, just theory. All of your original energy comes from the sun, and photosynthesis, it's generated from the sun, is converted into stored energy. And what are we writing here? Which one are we looking at? In the sun, changed chemical is stored in bonds. Oh, chemical energy is stored in bonds. Sorry, I wasn't reading that correctly. So not light, chemical energy is stored in bonds. All right. So question 12 and question 13. In this question 12, we have the equation, we have the delta H, and then it's just asking for 1 mole of CH4. If we were to do that, we'd notice that this equation is showing us 3 moles. So we just have to divide this value by 3, and we get negative 587.7, and that should be on the product side to represent that it is negative. This next one, looking at the heat of the reaction that is given, this would be a Hess's Law long question where we have our target. And in this question, we would just have to flip this second equation, which means we have to change the sign, and then everything else will cancel out nicely and we'd be left with our target. And so if we added those two values together, you would see your answer is A. Okay. Question number 14, we have some information about burning magnesium, where you get that bright white light. So we did a lab in this as well for Chem 30, where we did Hess's Law long. So which of the following represents the burning of magnesium? To get formation. So if you came up with the question, it would have magnesium plus oxygen to form magnesium oxide. If you're getting the value from your data booklet, you will end up getting a positive value, which is, I'm sorry, not positive. It would be a negative value because it's exothermic, 601.6. And that would be kilojoules per 1 mole being formed. So when it comes to balancing, instead of multiplying by some 2's, we can just add in a half here so that we can show 1 mole being formed. So now the reaction that supports this is going to be B, right? So just going through it, can't be A because that's endothermic. Cannot be C because it's showing endo and we need exo. And then this last one, it's not the right reaction because you have some oxygen. Looking at question number 15, the reaction represented above, because we see reactants are higher than products, this is an exothermic reaction. And if you included the term, it would be on the product side. So your answer is A. Looking at number 16, if you add in a catalyst, which that is, it would decrease activation energy. It doesn't do anything to energy released. Again, nothing to energy release. It just provides an alternate pathway, right? A lower activation energy. Question number 17, looking at methanol, showing which of the following represents the combustion of methanol in a closed system. If it's a closed system, you're going to get a liquid product for water. So you could do Hess's Law short and see which values work out. And then when you do this, so you use Hess's Law short, you'll find out that the delta H of the reaction is negative 1,451.8 kilojoules. So then the reaction that does support it would be C. Question 18 is NH equals delta H question. It tells us the amount of energy that is released. So you're getting the delta H of this equation when 1.65 grams is burned. What is the enthalpy of combustion? So you are solving for H here. So we would go 1.65 grams times the molar mass of methanol, which is 46.08. And then this is times hydrogen, your enthalpy of the reaction, and that's going to equal 44.7 kilojoules. So once you isolate H, you will see your answer is 1,248 kilojoules. So 1,000. So then, sorry, just looking at your answers here, your answer is D. If you put this into scientific notation, we would see that our answer is D. Okay. This is just a theory question. The reactants of photosynthesis. In photosynthesis, you want to take carbon dioxide and water, and you end up forming your glucose and oxygen. The products of complete combustion in an open system, so where water can escape as a gas, you end up getting carbon dioxide, which is 3, and water as a gas, which is 5. Question 19, asking about activation energy for the forward catalyzed reaction. Activation energy is always reactants to the top of the hill, but if it's asking for the catalyzed reaction, then we're going to the top of the lower hill, and so that would show 2 minus 1. Looking at another one where energy is released, if AgI is formed from its elements. So if it's formed from its elements, you can just use pages 4-5 to find the enthalpy of formation. And then we have moles. So this is an NH equals delta H question where we're finding the delta H. So we'd have 0.500 moles times your enthalpy of formation, which is negative 61.8 kilojoules per mole. And we want to plug that in to get delta H. And when you do that, you get the value 30.9 kilojoules. I'm sorry, my writing's getting even messier. The next one we're looking at, we have sucrose, some information, and it is being combusted, and it has a copper calorimeter that contains 250 grams of water, and then asks you the combustion of sucrose. So looking at this, we're solving for the molar enthalpy of combustion for sucrose. So we would look at this, and this is an NH equals negative MC delta T question. So the part about water, we have negative 250 grams. We know the specific heat capacity of water, and your temperature change was given 55.5. We are solving for H, and you know the amount of moles that was reacting was 0.015. And so now you're just going to isolate H. And then we have to remember, because of your specific heat capacity, joules per gram degree Celsius, when you calculate it, your answer will be in joules. You'll still need to divide it by 1,000 to get it into kilojoules. And when we do that and have correct sig digs, your answer will be D. Question 21. So we have some information about an experiment, and it was found that the theoretical value was lower than the actual value. So I feel like with this one, you can play around with it a little bit and see which one could explain. So if this was the case, so if I'm looking at my NH equals negative MC delta T, and looking at this H value, so what would make this H value lower than the theoretical value? So the one asking about the mass that was lower than measured, that would actually make it higher. And we can keep going. The first three, if we did look at it, would make it higher. Now, we didn't cover this yet in my class. We don't do it till organic, but it is going to, because the incomplete combustion of methanol is producing some other products. And because it's incomplete combustion, that's going to give you a lower temperature change, which would lower this whole side. In the end, would make that value lower than the theoretical. And I think that was the last question. So if you stayed with me this long, thank you. And please subscribe. If there's any other video I can ever do for you, just let me know in the comments. As always, thank you for watching.